Alright, we're almost done. So let's talk about heating and cooling curves. So if you're looking at the graph that is going to be beside this video, let's look at the first line. So we're looking at the bottom left hand corner. So the first line, let's say that's ice. So the ice is going to heat up, and then ice turns into a liquid. So that's at the melting point. So the next line is the melting point. So since we know that the solid ice has turned into liquid, so that tells us that the temperature is heating up. So let's keep heating up the temperature, shall we? So the liquid water, because the ice has turned into liquid water at this point, so the liquid water is essentially going to turn into water and steam. So we're at the next line, and it's vaporizing also, guys. So vaporizing, the liquid is vaporizing now because it's turned into water, and it's still water and steam, so it's at a boiling point. And so past the boiling point, if we keep heating it up, it's essentially just going to turn into all steam. And this all ties in together, because if you think about the slide before this one, it talks about evaporation. So evaporation has something to do with the heating and cooling curve, so keep that in mind. And so we're going to talk about the plateau now. So we know that we learned about, when we learned about the heating and cooling curves, we were told to remember the 3 P's, and that's plateau, phase change, and potential energy change. So we know that the the plateau is essentially that the plateau is about temperature, but it's about the temperature stays the same when it's in this phase, and the plateau on the curve marks the phase changes. But remember, the temperature remains constant during these phase changes. And that's all I have to say about the heating and cooling curves.